This is lesson 3. Sorry, this is the third video for lesson 1 in module 2. And again, we're continuing our look at multiplying and factoring polynomials, where we saw a visual representation of, multiplying monomials together here and then adding things together. We also talked about some factoring too. Specifically, we factored the greatest common factor, okay, in the previous video. And so now we'll just talk a little bit more about some different concepts that show up here. So a prime number is a concept that kind of is important for factoring and stuff. A prime number is a positive integer greater than 1 whose only positive integer factors are 1 in itself. So in other words, a simpler way to say that is a prime number is a number that's divisible by itself and 1 only. A positive number that's divisible by itself and 1 only. Evenly divisible, I should say. A composite number then is just if it's not prime. It's a positive integer that's not prime. Okay, so a composite number can be written as a product of positive integers with at least one factor that is not 1 or itself. So for example, 6 is a composite number, and it can be written as a product of 2 and 3, right? So it doesn't have to use 6 to get the product. But 7, however, is a prime number. Okay, and to multiply to get 7 using only integers, you can only use 1 and 7, right? There's no other numbers, no other nice non-fraction numbers that multiply to give 7 besides 1 and 7. Okay, polynomials, which is what we were working with up here. This is a polynomial right there. 1, 2, and 3 here were all polynomials. Okay, polynomials can also be prime. So not just numbers can be prime, but so can polynomials. Okay, a polynomial expression with integer coefficients is said to be prime or irreducible over the integers if it satisfies two conditions. So first of all, the polynomial cannot be just equal to 1 or negative 1, and if the polynomial is written as a product of two polynomial factors, each with integer coefficients, then one of the two factors must be 1 or negative 1. Okay, so in other words, a polynomial is prime if you cannot factor it any further, okay, just like a composite number. So for example here, this polynomial was not prime because we could still factor stuff out of it, right? And in fact we did, right, to here, okay? Now we would have to check to see, there's other strategies sometimes to factor, so sometimes we could factor that stuff out. But for example, like this does not factor any further, so we know that is prime, or 3h doesn't factor any further necessarily, so that is, prime. Well, anyway, yeah, okay. So the polynomial, we say the polynomial is factored completely over the integers when it is written as a product of C and one or more prime polynomial factors, each with integer coefficients. So completely factored means that you've pulled out the greatest common factor and then you've factored it the rest of the way that you possibly, as much as you possibly can't factor it anymore. All right. Of course, so part of factoring polynomials is also understanding how they multiply together. So what we're going to start with now is we're going to actually start with multiplying polynomials together to kind of get a feel for what that's like, and then that'll help us to better understand how to then factor or break or divide them up. So let's see this here. So one way to multiply two binomials, which again, binomials are just polynomials of the form a plus b, where you're adding two things together there. Okay, is to use a table. So for example, we can, let's say we want to multiply x plus 2 times x plus 5. Okay, so we will write x plus 2 on the side like this, and then x plus 5 across the top like this, and then we create, so really this is kind of like set up for us here. But if we came across this problem on our own, you could write x plus 2 like that, and then you kind of like create a little chart, and then you write x plus 5 across the top, and again create a little chart. And you'll notice I'm drawing the lines for my chart here through the plus signs, right? Through the plus sign here, through the plus sign here, and then also a line here to separate and a line here to separate as well. Okay, and then we just write the product of this. So in this cell, right, it's got the x and the x, so it's going to be x times x that we use to get that answer. And so this will just be x squared. You multiply there. Okay, to multiply it out. And then for this cell, well, again, that's the x and the 5. So it'll be 5x here when you multiply. And here it's going to be the x and the 2, so we're going to get 2x. Oops, I said x and I wrote a. Okay, and then finally here we have a 2 and the 5, so that'll give us 10. And we're just going to add these terms together. And voila, there's our answer. And that's the product of x plus 2 times x plus 5. Okay, an alternative strategy here that we can use, rather than using a table, is to take the x plus y and the x minus 5 here. Okay, and again, with this PDF, they already drew in all these arrows, and that's a lot to kind of look at all at the same time. So let me do it this way. Okay, we basically want to make sure that every term here multiplies with every term here too. So I'll use colors too. So in other words, this x needs to multiply with this x and this negative 5. Likewise, this y needs to multiply with this x and this negative 5 in order to multiply correctly. So let's do those multiplications. So the x times the x would be x squared. The x times the minus 5, minus 5x. The y times the x, that's going to be xy, or yx, however you want to write it. And then y times negative 5 will be minus 5y. Okay. Then once you've multiplied, you check to see, are there any like terms you can combine here? But the answer is no. Okay. You know, both of these terms have x's, but this one is an x squared, this one is just an x to the 1, so that's not going to be helpful to combine together. This term has an x and a y, no other term has x and y in it. And this has just a y, and no other term has just a y in it. So we know we're done, and that's the product. All right, we'll stop there, and we'll continue on in the next video.